And welcome back, students, as we continue discussing binary files. Today, we're going to wrap it up by talking about how to check for the end of a binary file. So, in order to discuss this, we need, of course, to discuss the EOF exception or the end of file exception. All of the object input stream methods that are read from a binary file will throw an end of file exception when they try to read beyond the end of the file. So, our code can test for the end of a binary file by catching an end of file exception as illustrated within the demo. So let's just quickly pop over there to the end of file demo. And you can see we have our import statements up here. And what we do is we have, you'll notice, a nested try block. All right, so we have a try block that creates the object input stream. And it says reading numbers in. And then it, of course, is going to try to attempt to read those numbers in. So while true, numbers equal to input stream.readInt. It's just not a print line number. And then, of course, it has an end of file exception catch right here because, again, you're reading numbers in from that data file, so you want to look for the end of file. Close the input stream. And, of course, then what it's going to do is it has its two catch statements here for the file not found and IO exception E. Now, of course, if you don't have a numbers.dat file, when you try to run this, you'll get a cannot find numbers file. So this right here is the file not found exception because, again, I don't have the numbers.dat file within this end of file demo. Now, if I had it in here, obviously it would show up. So, in the end of file demo, the reading is, of course, placed within an infinite loop through the use of true as a Boolean expression within our while loop. The loop, of course, is not truly infinite because when the end of file is reached, an exception is thrown and that ends the entire try block and passes control back to that of the catch block. So if we take a look at here, you'll notice right here, while true, there's nothing here that breaks out of this loop, right? But what ends up happening is it throws an exception, which pushes it out. So it would technically say no more numbers in the file. You would see that in your console here, and then it would just close the input stream. Right? So that's really all that's to it. Let's go ahead and continue. Because if your program is reading from a binary file using any of the methods listed in the previous lesson, so if we think back to our last one, we talked about reading from a binary file for the class object input stream, and your program attempts to read beyond the end of a file, then an end of file exception is thrown. Now, as you just noticed, this can be used to end a loop that reads in all the data in a file. The class end of file exception is also therefore a derived class of IO exception. So every exception of type end of file exception is also a type of IO exception. Now, a quick pitfall to mention here as you start checking for the end of a file, and this is doing it within the wrong way. There are different file reading methods to check for a file in different ways. So if you haven't checked for the end of the file the wrong way, one of two things will probably happen. Your program is either going to go into an unintended infinite loop, it's just going to keep going and going and going, it's never going to reach the end, or it's going to terminate abnormally. Your program's just going to crash. Now, for the classes that we've discussed within this course, the following rules apply. If your program is reading from a binary file, then the end of file exception will be thrown when the reading goes beyond the end of the file. So if it tries to get the next character, boom, end of file exception. Now, if your program is reading from a text file, then no end of file exception will be thrown when reading goes beyond that of the file. So this is kind of a key thing to remember. Binary file reaches the end of the file, boom, exception. Text file, end of file, no exception, right? Because they're functioning differently, all right? Because remember, binary file is not the same as a text file. All right, and that's kind of a quick one here today, folks. So we're just going to kind of wrap it up right there. And until next time.